Hi, and welcome back to Weekly Dev Tips. I'm your host, Steve Smith, aka R. Dallas. This is episode 33, in which we'll talk about different options for object lifetimes in web applications like ASP.NET and ASP.NET Core, and which one you should use for what. If you're enjoying these tips, please leave a comment or rating in your podcast app, tell a friend about the podcast, or follow us on Twitter and retweet our episode announcements so we can increase our audience. I really appreciate it. This week we talk about object lifetimes, why they matter, and how to choose the right one. We'll focus a little bit on Entity Framework since it's a very popular and also frequently misconfigured service. This week's sponsor is devBetter. I'm announcing my new developer career coaching program, devBetter.com. If you're not advancing as quickly in your career as a developer as you'd like, and you could use someone in your corner pushing you to succeed and opening up doors to new opportunities, check us out at devbetter.com and see if it's something that you might be interested in. Alright, so if you're not using dependency injection or following the dependency inversion principle in your code, you probably don't care too much about object lifetimes. You can probably just instantiate new instances anywhere you need them and then let them be destroyed when they go out of scope. In this case, you probably have no use for an IOC or DI container. However, your code is probably also very tightly coupled, making it more difficult to test and to reconfigure in the future. If it's working for you, that's fine, keep at it, but if you're feeling pain from the coupling, I encourage you to check out my solid principles and refactoring courses on Pluralsight to learn some different techniques to compose things. If you are using DI and containers, like most developers using ASP.NET Core where it's built in, or even ASP.NET MVC where you could add it yourself, you've probably encountered the concept of object lifetimes before. There's some variety in the nomenclature for some of the options depending on which IOC container you might be using, but using the terminology of ASP.NET Core's container, there are three main kinds of object lifetimes. These are transient, scoped, and singleton. Let me cover these briefly, and apologies if you're already well versed on this topic. Transient scope refers to objects that are created anytime they are requested. If you request an instance of a type from the container, and that type's scope is transient, you're getting a brand new instance. If you ask for a type, and that type has a constructor parameter of its own that's configured to be transient, that constructor parameter is also going to be a brand new instance every time. Even if you ask for an object hierarchy, and the same service is requested multiple times within the dependencies of that hierarchy, each one will be a separate instance that will be newly created for you. Scoped lifetime refers to objects that, once created, live on for the duration of a given HTTP request. If you ask the container for an instance multiple times within an HTTP request, you'll get the same instance back every time. Regardless of where the request to the DI container comes from within that web request, the same object instance is returned from the DI container. The first call to get an instance of that type will get a new instance, and every subsequent request for that type will get this same instance. Finally, there's singleton scope, which is very simple. There's only one instance. The first time an instance is requested, it's created, or you can create it during startup of your application and add it to the container at that time. Either way, after that, every time something asks for an instance of that type, that same instance is provided. So, which one of these lifetimes should you use? Well, naturally, it depends. Since we don't have a lot of time, let's just take a look at a couple of scenarios that involve Entity Framework or EF Core, which I'll refer to collectively as just EF. EF should be set up using a scoped lifetime, so that within a given web request, exactly one instance of an EF DB context is used. In ASP.NET Core, when you configure EF Core, the helper methods take care of this for you, so you never have to make a decision about what lifetime to use. In EF6, you had to figure this out yourself. Either way, if you are using the repository pattern, you have to make the right choice of lifetime for your repository instances as well. It's important that the right choice is used for EFDB contexts, specifically because they track the entities that they work with. As such, you can't have an entity that is tracked by multiple DB context instances. This will cause an exception. You also typically don't want to share entity instances between requests, That can cause bugs when two requests are making changes to an entity they both think they have exclusive access to. So let's look at some examples. Let's say you configure your repository instances to be transient. That means if you have two different classes within a request, like a controller and a service, and they both need the same kind of repository, they will each get a different, newly created instance of that repository. Now, assuming nothing else needs a DB context, what's going to happen is the first instance of the repository that requests a DB context will get a new instance of that DB context. The second instance of that same repository type will reuse that same DB context. When it makes its request, the DI container will give it the same instance of the DB context that the first one got. This will work just fine. However, there's probably no need to have two separate repository instances. You would probably be slightly better off if you made the repository use the same lifetime as the DB context, in this case, scoped. Now let's look at another possibility. Let's say you configure your repository instances to behave as singletons. Consider the same scenario in which a given web request needs the repository first in a controller and then later on in a service. The very first request to the web server will result in a newly created repository instance, which will then be reused forever after because it's a singleton. That first request will also get a newly created DB context, and that will then be passed to the controller, which is the first thing that's looking for that repository. Then, in that same web request, that service is going to get created, and it will be passed in the same repository instance. Notice that that repository didn't need to be created, so it didn't have to have its dependencies populated by the DI container. So it still has the same DB context associated with it. Now, this request completes just fine. Next, another user hits your website. A subsequent request comes in to the ASP.NET Core application. It will once again use that same repository instance because, of course, it's a singleton. And since it didn't have to create that repository, it's going to continue to use the same dependencies that that repository already has references to. In this case, it's going to have a reference to the same DB context that the previous request just had. But that instance, that DB context instance, was scoped to a web request that has now completed. So it's not going to work for this request. Or consider another possibility, which is that two requests are happening at the same time. Both will share the repository and its DB context, so any entities created and tracked will be shared between the two requests. If one request starts making updates to an entity, and then the other request calls save changes, those updated properties will be saved immediately, even though it may not be finished with making all the changes it wanted to. So you might get a partial update of an entity made back to the database. This could result in an error because maybe the state of that entity was invalid from the database constraint perspective. And in any case, it can result in behavior that you would not expect. This same thing can happen if you configure your DB context to be a singleton for much the same reason. So at the end of the day, the two things to take away from this is that your Entity Framework DB context and your repositories should have lifetimes that match. And in the case of both ASP.NET MVC and ASP.NET Core MVC, both of those lifetimes should be scoped. For other kinds of services, especially other ORMs like nhibernate, it's important you understand exactly how these types should be configured when it comes to their object lifetimes for web scenarios. That's it for this week. Thank you for subscribing to Weekly Dev Tips, and we'll see you next week with another great developer tip.